do with these things is that, I think I mentioned this the other day, I kind of skip around a little bit in chapter 14 as well. I take care of all the sine and cosine stuff, the generics, the parent functions, if you will, and then the next day I take care of the shifting. So we do the same idea with the tangents, because tangent functions look completely different than sines and cosines. So once we get, and there's different rules as well, so once we get sines and cosines going, then we just switch gears back to the tangents. We'll probably get to the starts of tangents tomorrow, but we'll play everything by ear. So today what we're going to do, we're going to go back to shifting. We're going to go back to A, H's, and K's, H values and your K values. And what you're going to find out here is that we still utilize the exact same rules and stuff that we talked about yesterday as far as the sine graphs and our generic cosine graphs are concerned. We still identify what our A value is, what our B value is. We write out our amplitude, we write out our period, but the only thing that's going to be different then, we also write out what our H is and what our K is. So do you guys remember what the H stands for in shifting? Horizontal. Horizontal is which direction? Nothing, right? And then K is your? Where to go? Gundy, I see you again. Yeah. It's like 8 times today.
You got a package coming in office.
Ooh. Oh, that's
He's
my
almost
controller.
done.
Yeah, the manager.
Our student teacher's almost done. He wants to see
I
him.
come back to work.
He's gonna be grumpy again.
That's right.
Yeah.
Yeah.
Those days are numbered, aren't they? That whole conversation is now on the internet for us.
Ooh.
That's true. I'm surprised you didn't. So here we go. Here's what they look like. And what I'm going to go through, you already know all this junk. What I want you guys to see is the new ideas. We know this. Y equals A sine B parentheses x minus h plus k. What does the h stand for again? It's your horizontal shift, and k is your vertical shift. Same thing goes for A cosine B x minus h plus k. They look identical to one another. We do the same stuff like you would with either one of them. We'll put them up here as well. And there's really no easy way of, or any perfect way of showing you guys what everything means right away, unless we just jump into examples. And what I like to do with these things is start with one shift at a time before I start mixing up all the shifts and putting them all together. Because what you're going to learn real quick here is, you know how we graph our parent functions? Remember we did exponential graphs, we would shift, we would put our parent function, we'd move the points over left to right, up and down. We do the exact same thing here, but as you recall when we graphed our sines and cosines, we always just made this kind of sideways T-chart. What's going to happen here is when we shift things left and right, we might adjust this to be a little bit longer, either direction, left or right. We might move this up or down, knowing ahead of time where our vertical shift is or our horizontal shift, or how high up or how low it's going to go. So you're going to see real fast, it's fairly simple, and it's the same exact process that we did yesterday. Okay. Let's look at an example right away. And of course, in this example, something changed. What's different between what I showed you with all the parentheses and stuff? You said something was flipped. What's flipped? K, very good. The K value has been moved. And the reason that they moved the K value here is because there's no H. And to alleviate the issues of thinking that that K value is an H, they put it in front. 99% of the time, your H value will always be in parentheses. It'll be parentheses x minus h. All right? Here, if they tacked on 4x minus 2, you might think that was, the h was 2, okay? So what they're doing here is they're just putting it out front to take away any of those issues. Does that make sense? Careful. Remember, look at what it is. A sine B. What's the 3? A. What's B? 4. What's H? 0. It's not there, so it's 0. And K is negative 2. So we start the same way. A is 3, B 4, K after, H is 0, sorry, that's bad, and K is negative 2. We always start these the same way. Each and every single problem we do today, and hopefully the ones you guys do in your homework, you do the same thing, label everything out. It is always better in the long run to have as much information written down before you get going. Same thing like we did yesterday. If our A value is 3, what's your amplitude? 3. Our B value is 4, so our period is going to be 2 pi divided by 4, which is half pi. Very good. And now this is what I'm going to worry about later. Those are going to be my shifts. Oops. Those are my shifts. So, since there's no horizontal shift here, there's just a vertical shift, all I'm going to worry about is making my T-chart, just like I would any other time. We start at the origin, and I end at the period. And now it's a matter of cutting things in half. Did you guys know that these fractional amounts you could find in your calculator? What you're finding here is the midpoint. And when you're finding these midpoints, if your period is in terms of pi, just leave pi out of it and use the fraction. So what's halfway between 0 and a half? Yeah, 1/4, so it would be pi over 4. Good. What's halfway between 0 and 1/4? Pi over 8. It shouldn't have eaten so much.
I get it.
Don't try to do it.
No, don't.
It was just like my before and
That's
after.
funny.
It was punny. I see what you did there.
Ooh.
Was that a P-H-U-N-N-Y?
I don't get that one.
Funny. Funny.
I lost now.
Just nod and smile.
Yeah.
Yes, Mr. Murphy. This is a sine graph. And make sure it was a sine graph. Now, what's happening between 1/4 and a half?
3/8.
3/8. Remember, your calculator will do that. In your calculator, if you don't know how to work with fractions, which is fine, take 1/4 plus 1/2 divided by 2. Math, enter, enter. You get 3/8. It tells you. Okay, so 3 pi over 8. Calculator will do the work. 1/4 plus 1/2. Did you hit enter then? There you go. So, in this case, we always start by graphing our parent function. It's a sine graph. The parent function for sine always starts at the origin. It goes to the amplitude.
It's funny.
Anyway, so we always start at the origin. The second one goes to your A value, back to the origin. The opposite of A, back to the origin. Now, do you guys remember when we did parent functions before? Did we connect those dots with a solid or a dotted line? Yeah, let's keep the same idea. Let's go with the dotted line. If you happen to have different colors, that's also helpful here. And move it up a little, make sure it touches. All right. Now, in this case here, there is no horizontal shift, but each one of these points needs to be moved what direction? Once again, there is no horizontal shift, so each one of these points have to go down to. Okay. So now, since my K value is -2, what I'm going to do is I'm just going to change colors here. Instead of being at 0, I'm going to be at -2. Instead of being at 3, I'm going to be at 1. Instead of being at 0, I'm going to be at -2. Instead of being at -3, I'm going to be at -5. Instead of being back at 0, I'm going to be at -2. All I did is just move it all down 2 points. And now, I just connected the solid line. All you're doing is graphing the exact same stuff that we did yesterday. We're calling that the parent function. And then with each of those points then, we move them left and right, up and down, depending upon what the values of your h's and your k's are. Okay. Hopefully that wasn't so scary. And just pay close attention to remembering the h value 99% of the time is going to be in parentheses. Let's try another one. Y equals 3 plus 4 cosine 2x. Our first step again, A, B, H. Okay. List it out. What's your A value? B. H. Okay. 3. Excellent. So is there a left or a right component to this? Nope. There's just a vertical component, correct? So everything's got to move up 3. I know my amplitude is 4, and I know my period is what? Can you look at that periods right away? It's going to be 2 pi over 2, so it is pi. Good. Now, I'm going to show you a little trick here. We know that every single point is going to have to move up 3, right? So instead of putting my line in the middle like this, I'm going to lower it down just a little bit, just to allow for that upper space so I don't run out of room. Does that make sense? What I'm doing is I'm using a little bit of foreshadowing? Is that what you're looking ahead? Yes. You're looking forward to your thoughts.
Yes, that's what it is.
Yes, that's what we're going to call it today. I'm using a little bit of 7 years ago thought, not to go to the play, but I'm going to know that I'm going to have to have a vertical shift there. Yes, it was an Abraham Lincoln reference. And I know some of you went, too soon. So now I know that all those points can just move up. So I'm just not going to use up as much space right off the bat, knowing that I'm going to go up here to 4. I'll be down here at -4 for my amplitude. I know my period's going to end at pi, so I cut it into my halves. And once again, this one's not going to be so bad to break apart. You had pi over 4, pi over 2, and 3 pi over 4 were your break points, your critical values, if you will. It's a cosine graph, so where do you start at? 4, yep. We start at our A value. Our A value here is 4. I go to 0. I go to my opposite A value. I go to 0. And then I go back to my A value. You guys know why I'm saying opposite of A value and not positive A or my negative A? It's absolute. Because remember, your A value could be negative to start with. And if it was negative to start with, I would start down here and work my way the other way. Okay? Just a little heads up on that. Connect the dots. La 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 la. And what do I do to each one of those points? Move them up 3. Good. So instead of being at 4, I'm at 5, 6, 7. Instead of being at 0, I'm at 3. Instead of being at -4, I'm at -1, 3, and back at 7. Now, does it have to look perfect? Of course it does. Make sure that your values that you're shifting, your new points, are labeled, whether it's on the y-axis or it's on the x-axis. Make sure you label those points. Okay? I'm expecting to see tick marks and values and stuff. Right. Your vertical shifts are usually a little bit easier than horizontal shifts. Watch. Shall we try some horizontal shifting? It's exciting. Let's just jump right in. You may look at that and go, uh-oh. So we have y equals 2 cosine of 2/3 times the quantity x minus pi over 4. So in this case here, do you guys notice how the h value is grouped within the parentheses? That's what you're going to see. You're going to see parentheses to know that you have an h value. Do I have a k value here? No. So there's no horizontal component. So I start the same way. There's no vertical component. I misspoke. A value is 2. B value is 2/3. H value, see if you remember this. What's your h value? It's pi over 4. Good. Remember, it's the opposite of the sign. Good. And the k value is 0. Remember that trick. If you're dealing with h values, change the sign. K value, keep the sign. So this, every one of these points is going to move what direction? To the right, pi over 4. Okay, you just told me it was pi over 4, so you can move these. Oh, yeah. So start by making our graph. We know we're going to move everything to the right at the end. Oh, we got to figure out our amplitude and stuff first. Forgot. Our amplitude, well, it's 2. And our period, see if you can figure this one out. 3 pi. It's 3 pi, very good. Remember, when you take this, it's 2 pi divided by 2/3 gives you 3 pi. Multiply by the reciprocal or put everything in parentheses in your calculator and it will work. Right? So I know at the very end of a full cycle is 3 pi. Does everybody see how I did not put it at the very, very, very end of my little chart? The reason I did that was to allow for the new point at the very end to be pi over 4 more. Does that make sense? So that way I'm just knowing that I'm going to have to move that point anyway, so I might as well make my graph a little bit, just adjusting the scale right off the bat. It's just working ahead here. So break your half points. Half of 3 is 3 over 2. Half of that is, well, it's 3/4. Yeah, 3 pi over 4. Now the tricky part. What's halfway between $1.50 and $3? 9/4. Very good. All you have to do here is get to another shortcut. If you don't have a calculator in front of you, usually what happens when you get down to this very last one closest to the origin, that'll probably be the simplest fraction you're going to use. It's going to be the common denominator all throughout. If this is 3/4, if I double it, it's 6/4. Add another 3/4 to it, I get 9/4. And this is the same thing then as 12/4. Ready to see what I'm doing? Each one of these is 3/4, 3/4, 3/4, 3/4. That's the spacing between all of those. So what I'm doing is just working that in my head. Or use your calculator, press a couple of buttons, and go. If you have problems getting the buttons correctly or setting it up, make sure you stop and flex it, and I'll show you guys real quickly how to do that. Real quick. All right. Our A value is 2. Our opposite A value is -2. It's a cosine graph, so where do you start? Start at 2 in this case. And I cycle through. Connect the dots. And now I have to adjust my scale. Each one of these points needs to move to the right pi over 4. Okay? So instead of being at 0, I'm now at pi over 4. Do you agree? Okay. Instead of being at 3 pi over 4, I add a pi over 4 to it. I'm at pi. Remember, this is 6/4. If I add a 4th to that, I'm at 7 pi over 4. If I add a pi to 9/4, I'm at 10 pi over 4. And I know that I can simplify it, and I'll get there. Oh, I didn't even put a dot here. And then this was 12 over 4, so it's 13 pi over 4. So all I gotta do is adjust my points. So it's here, here, here. And I connect them. Then I just moved everything over pi over 4. The trickiest part for a lot of these things for you guys, knowing how much you love fractions, is to be able to adjust your horizontal scale. Okay, that's going to be the trickiest part for you guys. So make sure that you just use your calculator and add in. All right. That 10 pi over 4 is how much? Yeah, 5 pi over 2. Okay. You guys are all waiting for it to get worse, or are you okay? Well, we haven't done horizontal and vertical at the same time, so that's about as tricky as this stuff gets. I think I have one more horizontal, then I'll get you a tricky one. Do this one on your own? Yeah, I guess. Yeah, you can't make fun of them too much. One of these things will get mad at you. All right, let's see where we're at. With any luck, we should be okay so far. Our amplitude is 1, our period is 2 pi, and all we have is a horizontal shift of pi over 2. We all agree on that? Okay. There's 2 pi. I'm going to have to go to the right a little bit more. 1, negative 1. Pi, pi over 2, and 3 pi over 2. You got those for all of your breaks, I'm hoping. Right. It's a sine graph, so it starts at your origin, goes to the A, origin, or 0 I should say, opposite of A, 0. Connect the dots. And now for each one of these things I have to create a new scale. Well, this one's really, really, really easy because your breakpoints are already there for you. You move everything to the right, pi over 2. So as I move everything to the right, pi over 2, instead of being at 0, I'm now at pi over 2. Instead of being here, I'm at pi. Instead of being here, I'm at 3 pi over 2. Instead of being here, I'm here. What's my last value going to be then? Excellent. It's 5 pi over 2. Remember, you're adding 2 pi plus a half gives you 2.5. And now we connect them. Because you guys are having fun. Fine. Let's do it all at once now. Let's make this a lot tougher. All right, so we have y equals 8 sine 1/2 x plus 4 pi minus 3. All right, smarty pants. Do that one. When you have horizontal vertical shifts going, I know by now you guys are probably doing just fine identifying your A is 8, your B is 1/2, your H is negative 4 pi, and your K is negative 3. I'm assuming everybody's got that down pat. Okay. I know my amplitude is 8, and my period is going to be how much? 4 pi, yeah. I'm going to have to move every point to the left 4 pi and down 3. Since I'm going to have to move everything from the left, what I'm going to do is put my kind of in the middle like this. It's just a little, just to get ahead of it. All right. And also, since I'm starting at 8 and I'm working my way down, it doesn't actually, that probably doesn't matter all that much. Maybe a little bit longer underneath here. So it's a sine graph. We started our origin. We're going to end at our period, which is 4 pi. Your breakpoints are really, really, really easy now. 2 pi, pi, 3 pi. You agree on that? It's nice when it works out like that, huh? Your amplitude, your A is 8. The opposite is -8. Sine starts at 0, goes to your A value, 0, opposite of A, 0. Now, each one of these points goes left 4 pi and down 3. So instead of being at 0, I'm going to be at -4 pi. Instead of being at pi, I'm -3 pi, -2 pi, and -1, or just -pi. It's very nice when it's clean like this. Okay? It's not always this clean, just so you know. So now each one of these points, instead of being at 0 now, it goes down to 1, 2, 3, -3. So I'm all the way over here at -4 pi, -3. Instead of being at pi, I'm at -3 and 5 pi, or excuse me, just 5. The points? Yes. Yeah. I want you to at least tell me what your new scales are, okay? Once again, instead of being, I'm at -2, -3. Instead of being at -8, I'm at -11. And then I'm at 0, here again at -3. And there's your shift. Doesn't have to look pretty, but what you need to have on your papers are your horizontal shift values now and your vertical shift values. Just change your tick marks on your scale. Okay? And you should be okay. Ready for some problems? Yay! Yay! Oh, let's see, page 845. I'd like you to do 32 through 43. All. Those are all graphing problems. Not even gonna bother identifying periods and amplitudes and all that stuff. We're just gonna go right from there. Okay. Pause this and set this up. Okay.